Hello everyone, welcome to Olsen Cafe. In this video, I will be starting a series of lessons on circle properties. So this particular video, I will cover all the properties that you must know related to circle. I will not attempt to solve question here, but it will be done in my next video. The first property that I'm going to introduce here is symmetrical properties of circle. So what you see here is there is a chord TS. Yeah, so with this chord TS, and if we have a perpendicular bisector of a chord, so this perpendicular bisector is known as OW. So this OW perpendicular bisector, it will pass through the center of a circle. Now, the other way around, it is also true, which is conversely, that is, if there is a perpendicular line, which is OW, so there's a 90 degrees. If this perpendicular line is drawn from the center of a circle to this chord, all right, so I will know that this perpendicular line OW, it will bisect the chord. So bisect simply means it will divide the chord into two equal halves. So for this particular property, right, it is very useful for those students who are learning additional mathematics under the chapter or on circle, all right, whereby we need to find the center of a circle. So this is the concept that we usually apply over there. Okay, the next property that we have over here under symmetrical properties of circles will be two equal chords. So as you can see here, so we have two chords ST and UB. So these two chords are of equal length. So if they are of equal length, then what we also know, right, it will be the distance from the center will be also the same. So that's why you say here, chords with equal length are equidistant from the center of a circle. So for this type of questions, right, it will usually come together with Pythagoras theorem and also Tuakaso, right, which require you to make use of these two theorems to find the unknown sides or the unknown angle. Now we move on to angle properties of circles. So the very first property that we are going to introduce here, all right, is known as angle at the center equals to 2 times angle at the circumference. So what you will see in this diagram, right, you will have angle at the center. So this angle at the center is actually subtended from this chord KL. And you also see that angle at the circumference KQL over here, it is also subtended from the same chord KL here. Yeah. So what this property simply tells you that for this angle Q, if I have any angle that is come from the same major arc, which is the green color here, so there's any angle, right, that falls on this green arc, which is major arc, it will be half of 136, provided that the angles are from the same chord KL. So for this first property, it is still easy to identify. Let's move on to the next type of question. Over here in this slide, you will notice the diagram looks slightly different. It is still under the same property, which is angle at the center equals to 2 times angle at the circumference. But what you will notice is that in this diagram, right, to find angle at the center equals to 2 times of the circumference, it is no longer angle POG. So what you must be able to identify, which is the reflex angle over here. So this reflex angle is the one that is 2 times angle of the circumference is 102 degrees. So the common error that students make, right, a lot of students, right, tend to say is that angle GOF, which is this angle here. Yeah, so do take note, this angle GOF is not 2 times angle of GLF. Yeah, to apply angle at the center equals to 2 times angle of the circumference for this type of diagram, right, it has to be the reflex angle. What happens when we have a chord becomes the diameter of a circle? As you can see from here, LM is known as a chord, but this chord now it is a diameter because it passes through the center of the circle. It is worth to take note that diameter, it is the longest chord of a circle. Now, if we're going to apply what we have done earlier on, so we know that in this case, this angle here, angle at the center, it is 180 degrees. So by first property, we know that angle at the center is equals to 2 times angle at the circumference. So this angle LNM here, it has to be half of 180 degrees, and hence this angle is equals to 90. So this is how we derive the second property, right angle in a semicircle. So do take note of this word right angle. All right, so usually a lot of students, right, when they write down the property, they tend to miss out this word right angle. Yeah, so this is something to take note. Okay, we'll move on to the next property on circles, which is known as angles in the same segment. So in this particular property, what you can see on the diagram here, right, it seems, some of you all call this the butterfly property. Yeah, so what you can see here, all right, let's get to the term. We have a minor segment, which is the white area over here, and then we also have the green portion, which is also known as the major segment. So what you can see is that there is a chord LM. So you'll notice that all the angles, all right, angle LBM, angle LCM, and angle LDM, and they are all the same angles from the major segment. So in this property, what we know is that angles in the same segment, they are all equal. Right? To apply this property, the important pointers that you need to take note is that all the angles must be from the same chord. Right? If the angles are not from the same chord, right, you will not be able to apply, the rule will not be the same. You will not be able to apply this property, angles in the same segment. So that is something whereby you need to take note. They must be from the same chord. Now we are done with angles in the same segment. What we have here will be angles in the opposite segment, as I have introduced earlier on. So in this yellow segment that you see here is a minor segment, and then you have the major segment in green over here. So what you observe in this diagram, you will see that there is an angle that is on the minor segment, and then there is another angle that is at the major segment. So this property is called angles in the opposite segment is simply because the two angles are opposite one another in the different segment. Yeah. So to apply this property, what is important is you must be able to identify a cyclic quadrilateral. This word cyclic quadrilateral is simply means that all the 4 points of the quadrilateral, which is over here, L, F, K, E. So these 4 points of the quadrilateral, right, it must be on the circumference of the circle. So this is the important point, the important definition of a cyclic chord. So what you see here is you have an angle L. So this angle L, as I said earlier on, it is in the minor segment. Then I also have angle K over here, which is in the major segment. So in this case, what we do know is that the two opposite angles are supplementary. So supplementary simply means when they add up together, it will be equals to 180 degrees. Let us practice how to identify angles in the opposite segments over here. So are you able to identify the cyclic chord? Are you able to identify that A, B, C, D is a cyclic chord? So what you have, you notice that the 4 points A, B, C, and D, these are the 4 points that lie on the circumference of the circle. Yes, so that is why it is a cyclic chord. Now, how about O, A, C, D? O, A, D, and C. Is this O, A, D, C a cyclic chord? Yes, the answer is no. All right, it is simply because point O here, it is at the center. It is not on the circumference itself. So therefore, OADC, it is not a cyclic chord. How about this diagram? are you able to identify the cyclic chord? So if we make some observation, then we will be able to see that all the points on the circles here, they are already on the circumference of the circle. But again, from the term quadrilateral, that means what we must be able to identify is just 4 points. So what we can see is we have A, E, D, C on the circumference of the circle. So we have one cyclic chord over here. And the other one that we have is we have point A, B, C, D. So this particular quadrilateral, it is also known as the cyclic quadrilateral. So in this diagram, we have two cyclic quadrilateral. All right, now we move on to the last part of the property of circles. So in this case over here, all right, we see two tangents. All right, what we see here is AT and BT are known as the tangents to the circle, and they are known as tangent is simply because that we have this line that touch the circle at one point, which is B, and similarly for the other tangent AT, it will only touch the circle at one point, all right, which is at A. There is another term that is what we call here external point. So T is known as an external point. So external point is simply mean this point is outside of the circle. So we have this external point over here. So with this external point, all right, what we observe is if we have these two tangent, right, you notice that OT is actually an angle bisector that bisect angle ATB. So you can have 21 degrees and the other half 21. So similarly, we have 69 degrees and 69 degrees over here. So indirectly, we are saying that, all right, because of this tangents from external point, we know that triangle OAT and triangle OBT, they are actually congruent. Now, are you able to identify this angle here, which is where my pointer is? All right, so that this angle here, the first property actually tells us all because it says tangent perpendicular to radius. So we have tangent AT and then we have OA as the radius. So based on the theorem that we have here, right? So it is easily for us to know that the angle OAT, it is 90 degrees. And similarly, we also know that the angle OBT, it is also 90 degrees. Yeah, so this is simply from tangent perpendicular to radius. Now with this, so I have covered all the properties that we need to know on circles. So the first two properties, which is related to the symmetrical properties of circles, and then the subsequent one, number 3 to number 6, which is all on angle properties of circles, and with the last two properties that is related to tangent. Yeah, so here's a summary of all those that you must know. In my next video, I will be going through with you on how to identify the property circles in a given diagram. All right, and then with the skills, then we will be able to solve. All right, see you then. Bye bye.